87 47 933 08 8 088150 इसको कीजिए मैम
Recording in progress. Recording in progress.
Hello.
Hello.
Yes, Priyanka.
Yes, sir. I shared my slide and whole presentation. Does it clear?
So you are in the last slide, conclusion.
Conclusion.
Yes.
Actually, I stopped sharing. Can I restart it?
Next. So now you can leave the meeting. Now we are starting the next presentation. So next presentation is Sangeeta Gupta. Priyanka.
Hello, good afternoon, everyone.
Good afternoon, Sangeeta. So you have the 8 minutes plus 2 minutes for question.
Okay, sir.
Okay. So try to finish within time.
Okay.
Now you can start.
Good afternoon, everyone. I'm going to give presentation on the topic. I'm Dr. Sangeeta Gupta. I'm assistant professor in Bharatiya Vidyapit, and I'm also alumni of NSUT. Last year, I completed my PhD from there. So I'm going to present my paper on the topic impact of integration of renewable energy source on optimal power flow, along with the co-author of this paper, Dr. Saket Gupta. So first of all, the outline of the presentation is first I discuss about the optimal power flow, then OPF solution methodology, problem formulation, and these are. So what is OPF? OPF means optimal power flow is one of the fundamental mathematical tools currently used for the operation of power system. In general term, we can say that optimal power flow determines the dispatch of generating units to satisfy the electricity demand at the minimum cost, and the target to achieve the steady state analysis by determining the voltage angle, real power, reactive power, lines flow. It has been started since 1960 by Carpentier, and it was addressed more in 1979. So the input, there are some input and output of optimal power flow analysis in which the bus data consists of system parameters, which active and reactive power. Line data consists of serial resistor, capacitor, and inductor. Generator means the maximum power generation, load data. These are the input data for OPF, and the output of this one will get voltage magnitude, voltage angle, reactive power, line flow, and power losses. So the problem for the solution methodology means what are the optimization technique I'm going to use. The optimization technique which I'm going to use in this research paper is from meta-heuristic, but the optimization method is basically classified into two parts, classical method and meta-heuristic. So meta-heuristic is derived from the combination of two words, meta and heuristic, whereas the meta stands for beyond and higher level, and heuristic means to find or generate or act as a partial search algorithm. So these are the meta-heuristic algorithms in which I'm going to use the SOM-based meta-heuristic algorithm. The meta, if the efficiency meta-heuristic, why we use the meta-heuristic algorithm? Because it gives the better efficiency and simplicity in its concept and implementation. It can evade the local optima problem of local search technique and does not require any ample any past data information for the optimization. So that there are several meta-heuristic nature inspired. So basically the SOM-based is one of the meta-heuristic algorithm. This is the formulation of OPF, problem formulation, which can be mathematically depicted as a minimum f of xu. X stands for state variable and u is the control variable, as you can see in all the equations. There are two constraints by which we can define the OPF problem: equality constraint, which are defined by equation number 5 and 6, and inequality constraint, which are generator constraint, the transformer constraint, shunt, and security constraint. So the meta-heuristic algorithm, along with the pattern search, means we have proposed a hybrid algorithm because any of the optimization technique, there are two main techniques, exploration and exploitation. So we are doing the exploration part with the one algorithm and exploitation part with the another algorithm. And we have tested this algorithm on the first test system, which is IEEE 30 bus, which consists of 41 branches, 6 generator, load bus, 24 load bus, and 24 control way, as you can see in the diagram. These are the complete details of the system. And the second test system is IEEE 118 bus test system, which consists of 118 buses, 186 branches, 54 generators, 9 transformers, and shunt VAR of 14. So these are the complete specification of second test system. There are 5 objective functions we have taken: fuel cost optimization, the mathematical interpretation of this is given by equation number 7, total voltage deviation, voltage stability enhancement, real power losses, minimization, emission minimization. These are the 5 optimization objective functions we have taken to validate the proposed algorithm. So basically the first algorithm optimization technique is Menta-Ray forging optimizer, which was developed in 2020, and it is inspired by forging strategies of Menta-Ray. Menta-Ray is fancy creator which belongs to the marine life, and it has a lifespan of around 50 years, and usually it is of 25 feet long, 1350 kg, and the main food is planktons. Planktons is also a fish. There are 2 types of Menta-Ray. One is reef Menta-Ray and second is giant Menta-Ray. Reef Menta-Ray basically found in Indian Oceans, and it is of 5.5 meter of width. Giant Menta-Ray is basically found in high temperature oceans, and it has the biggest brain. Menta-Ray algorithm, the forging behavior, the behavior is divided into 3 parts: chain forging, cyclone forging, and somersault forging. As you can see in this figure, the chain forging, this one. So in chain forging, more than 50 Menta-Ray lined up one behind another to find the best optimal solution. Firstly, Menta-Ray observe the position of the planktons and swim towards it. and it forms a tail lined up from head to tail. And best solution is where the concentration of planktons are high, and in every generation, all individuals will update their position with respect to the solution in front of it. And the mathematical representation of chain forging is here. The xi is defining the individual food, and xt based is the plankton with high concentration. Alpha is defining the weight coefficient. The second is cyclone foraging, which is also used by whale fishes with this same strategy. The cyclone foraging, when the plankton's concentration is very high, again gather together like a cyclone structure foraging, and they form a long foraging chain and swim towards the target by spiral. And third is somersault foraging. In somersault, when mentor forward find out the food source, they circle around the target, means the planktons, and this strategy is random and contains cyclical movement, and each individual swim to new position. Update is done around the base solution found, and there are equations which you can see in this one. Now the pattern search will be discussed by the Dr. Saket Gupta.
Hello, am I audible? Hello.
Yes, you are.
Hello.
Yes.
Optimization algorithm, MLF2 algorithm also suffer from the premature convergence, so that in this paper we will combine the two optimization algorithm, pattern search and MLF2 algorithm, to overcome the limitation of MLF2 algorithm. Pattern search algorithm is a local search algorithm to improve the solution of the evolutionary computing method. Next slide, please. So this is the diagram of pattern search algorithm. Each pattern are moved according to shown in figure. Next. Result, and this is the flow chart of proposed algorithm. In this, first step is initialization of the parameter. Second step, after the getting the best solution, the pattern search algorithm is improve the getting the solution, so that we will get the global optimum solution. The flow chart show the working principle of the hybrid test. Next slide, please. So in this term, the proposed algorithm is developed MATLAB environment 2019 A version. This is the result of IEEE 30 bus system. In this proposed algorithm applied for 5 objective functions. Table, second column represent the fuel cost minimization, second column is voltage deviation, third column is, fourth column is L index method to improve the voltage stability, and fifth is the emission minimization, and sixth last one is bubble. So in this table, third column, we will see the fuel cost minimization is obtained in the proposed algorithm 79999.60. This is the 2% improvement conventional MRFO algorithm. Similar, the other objective function also improve the proposed algorithm. This is the per hour reduce the fuel cost. If we calculate the 24 into 65 days, this is the huge amount of saving of the fuel cost. So this is the advantage of proposed algorithm to solve the real-time OPF problem. Next slide.
So you have only 1 minute. Please wind up.
Okay. This is the convergence characteristics of the proposed algorithm. Next algorithm. Next slide, please. Next slide. This is the after implement 1 DG, the numerical results shown in figure, table number 4. Next slide. This is the convergence characteristic after the implement 1 DG. Right, please. Next slide. This is the result of 118 bus system. You will see that first. So in this system, we will improve the fuel cost at 8.362%, which is in terms of dollar, $1,060 per hour in the fuel cost. If we calculate the yearly value of the cost, it is around the 15.41 million fuel cost, 15.41 cost dollar of the fuel cost. Next slide, please. This is the convergence characteristic of the proposed algorithm with and without DG. Next slide, please. So conclusion. So the main disadvantage of conventional algorithm, they are trapped for the local optimum solution to overcome the drawback of the conventional optimization technique. In this paper, we will propose the hybrid version of the two algorithm, two evolution computing algorithm to overcome the shortcoming of the proposed conventional algorithm, MRFO algorithm. So in this previous slide, we will clearly see that the proposed algorithm significantly reduce the fuel cost and other objective function. This objective function use power system engineer and system operator to future planning of cost-effective planning of power system and other domain of future extension of the electricity board system. Thank you. If you next slide, please. This is the major differences.
Okay, thank you, Sangeeta and Saket, for nice presentation. So, any question? So, there is no more question. So,
Thank you, sir.
we are moving
Thank
to the
you,
next presentation. Anvesh Parasar.
Good afternoon, sir. I would like to start my presentation.
So, Anvesh, you have 8 minutes.
Okay, sir.
हेलो अन्वेश अन्वेश का है किसका है आई एम आस्किंग यू टू अनम्यूट प्लीज अनम्यूट योरसेल्फ या नाउ यू आर ऑडिबल प्लीज स्पीक अप अन्वेश
Good afternoon, sir. Sir, I'm Nsut Parashar.
yes you are audible now
Okay, sir. Thank you so
yeah
much.
you can go ahead
Okay, sir. Sir, Anupam would like to take the lead as the presenting author.
so Anupam we need to unmute Anupam
Yes, sir. Anupam Thakur.
Anupam now please unmute yourself
Yes, sir. Yes, sir. Yes, sir. Can you hear me?
yes we can hear you please go
Yeah.
ahead
Yeah. So this is a review paper on a comparative analysis of heterogeneous and homogeneous catalyst-based ozone treatment for degradation of industrial wastewater. I am along with Anvesh Parasar, Saurabh, and under the able guidance of Anil sir. So the thing is, background of the study, why we choose this review paper. The first and foremost thing is industrial wastewater is a major environment challenge resulting from various industrial activities. And it frequently contains variety of dangerous contaminants and chemicals such as dyes, and most prominent one is the azo dyes and the colors which are present in the effluents which has been disposed of by the industries. This is seriously endangering aquatic ecosystems and human health. Dye is highly hazardous component of wastewater, and due to its complicated chemical composition, it is resistant to chemical and biological treatment. Industrial wastewater frequently still contains dyes despite conventional treatment procedures, demonstrating the urgent need for efficient and long-lasting solutions to this problem. Now, one may ask that why ozone treatment? The ozone treatment has become one of the most highly promising approach for the effective degradation of dye pollutants in wastewater because of its high potential for oxidation and capable of producing reactive oxygen species that are efficient at dissolving colors. Anvesh, can you move on to the next slide? Yeah. So the objective of this research, the aim of this research is basically to compare and analyze the efficiency of heterogeneous and homogeneous catalysts in the degradation of dye pollutants in industrial wastewater using the ozone treatment process. This study intends to compare the efficiency of heterogeneous and homogeneous catalysts in dye degradation, investigate the influence of different factors such as catalyst type, dosage, their acidity levels, their catalytic activities, and the catalyst. The third is to evaluate the potential of the catalyst and provide insights into the mechanism of dye degradation by the catalyst under ozone treatment. And Vish, can you move on to the next slide? Yes. So the most prominent question is why you are choosing ozone, why not other chemical substances? So here I have overviewed the use of ozone for dye degradation in wastewater treatment. The thing is, ozone has been recognized as a potent oxidizing agent for the degradation of dye compounds in wastewater treatment. The use of ozone is advantageous due to its ability to effectively break down the dye molecules into simpler and less toxic compounds, leading to improved water quality. Ozone can be generated on site using specialized ozone generators, and its application in dye degradation is a cost effective and environmentally friendly approach. The treatment has the potential to reduce the use of conventional treatment methods such as activated carbon adsorption, membrane filtration, which are mostly costly and have limited effectiveness for the removal of certain types of dye. However, it should be noted that the use of ozone requires monitoring and ensuring that the byproducts of oxidation do not pose any additional risk to the environment and also to the human health. So, can you move on to the next slide, Anvesh? Yes. Then there is the mechanism, as in how ozone treatment is processed. The ozone treatment is basically comprised of uh, three steps. The first one is the initial reaction. It goes like when ozone is introduced into the water containing dyes, the ozone reacts with water molecules and generate hydroxyl radicals. These radicals subsequently react with the dye molecules, resulting in the production of intermediate compounds that are generally less stable and more reactive when compared to the initial dyes. The second step in this mechanism is the intermediate products which has been formed in the initial reactions undergo additional oxidation by hydroxyl radicals, resulting in the formation of simpler and smaller compounds. The process may entail the cleavage of chemical bonds and creation of new functional group. For example, aromatic rings, which are present in the effluents, may disintegrate into aldehydes, alcohols, and carboxylic acid. The last step is mineralization. In the ultimate phase of dye degradation, the complete mineralization of organic compounds occur, converting them into the organic substances like carbon dioxide, mineral, water, etc. This stage usually necessitates the participation of microorganisms that can break down the intermediate products produced during the oxidative degradation stage. On to the next slide, Anvish. This is the basic comparison between the homogeneous catalyst and heterogeneous catalyst in the degradation process. The homogeneous catalytic ozonation is marked by two possible mechanisms. The first one is the formation of free radicals through the decomposition of metal ions, and the generation of complexes between the catalyst and organic molecule, followed by the oxidation of resultant complex. In the case of heterogeneous catalyst, catalytic ozonation, the activity of catalyst is very pivotal, and the adsorption of ozone and organic molecules on its surface is imperative for catalyst to manifest its efficacy. Overall, the mechanism of heterogeneous catalysis for dye degradation using ozone involves the catalyst providing additional active sites and additional reactive species. This is the most prominent mechanism that can aid in the degradation process. On to the next slide, Anvesh. So, in conclusion, in comparison, everything, the challenge that persists in formulating heterogeneous catalysts that are both economically viable and efficacious with high levels of stability and activity. Homogeneous catalytic ozonation is characterized by ease of operation and to ability to enable exacting regulation of reacting parallel emitters, but the utilization of transition metals ions in this method can result in the generation of byproducts which may prove challenging when eliminating or disposing of from treatment of water. Overall, the selection of appropriate catalytic ozonation method depends on various factors, including wastewater treatment objectives, the pH levels, the acidic, then the catalysts which are available, the economic feasibility, and the cost of suitable catalysts. So this was it. Anvesh?
So I would like to add something. Right now, the development of catalysts is as such that we can also use catalyst chips, in which we are integrating the heterogeneity and homogeneity of the catalysis process. And the benefit of this process is that even after repeated use, even after 10 usages, the efficiency of removal of dyes in one Zhu et al. Conducted a research in which they removed the basic yellow 87 dye, in which even after 10 usages of the catalyst, which was a porous copper fiber catalyst, which was comprised also of copper oxide, zinc oxide, aluminum oxide, and zirconium oxide. And the efficiency still remained at above 99%, and it also reduced the half-life, that is the amount of time taken by the dye to be removed from the wastewater by half. So that was even that is a major significant. This could be a region of further research in the coming times. Thank you, sir.
Thank you, Avnish. So, any question? So, I think there is no questions. Once again, thank you, Avnish, for nice presentation.
So thank you very much, Professor Rajesh, for conducting such a wonderful session and chair the session very nicely. Would like to present a certificate of appreciation to you.
Recording stopped.